How to prevent reentrancy issues in microcontroller ISRs. Imagine your microcontroller is like a busy traffic intersection. When an interrupt occurs, it's like a car coming through. If the same car tries to go again before the first pass is finished, chaos can happen. That's what reentrancy issues are in microcontroller interrupt service routines. They happen when an ISR is interrupted and then reenters itself before it finishes. This can cause data corruption or unpredictable behavior. So how do we keep our microcontroller traffic flowing smoothly? The key is managing shared resources carefully and controlling how interrupts are handled. First, design your ISRs to only access data that is safe for concurrent access. Use data structures like queues or buffers that are built for interrupt safety. Avoid changing global variables directly unless you protect them. Second, use synchronization techniques like disabling interrupts during critical sections. This means turning off certain interrupts temporarily so they don't interfere while you're updating shared data. In some microcontrollers, you can mask or block interrupts of the same or lower priority level. Third, assign priorities to your interrupts. Higher priority interrupts can preempt lower ones, but lower ones should not interrupt higher ones. This prevents conflicts and reentries. Many microcontrollers have nested interrupt controllers that let you set these priorities precisely. Fourth, keep your ISRs short and simple. Long or complex routines are more likely to be interrupted again. Instead, just set a flag or push data into a buffer and let the main program handle the heavy lifting later. Fifth, always clear the interrupt flag inside the ISR. If you don't, the interrupt might trigger again immediately, causing reentrance. Sixth, declare shared variables as volatile. This tells the compiler not to optimize away reads or writes, ensuring data consistency. Seventh, avoid calling functions inside ISRs that are not reentrant. Functions that relying on static or global data can cause issues if reentered. Lastly, in systems with nested interrupts and shared resources, use priority ceiling or priority inheritance protocols. These help prevent lower priority ISRs from blocking higher priority ones, avoiding deadlocks and reentrance problems. For example, if your ISR pushes data into a queue and signals the main loop to process it later, the ISR stays short and safe. By managing interrupt priorities, protecting shared data with proper structures, keeping ISRs brief and clearing flags correctly, you can prevent reentrancy issues. This makes your embedded system more reliable and predictable, ensuring smooth operation even when multiple interrupts happen at once.